Hi everyone, welcome to the A.CED.4 Level 1 note video. So we're going to be solving literal equations within this standard. What a literal equation is it's an equation involving two or more variables. So for a level 1, we're only going to be dealing with two variables. And now just because we have more than one variable in an equation doesn't mean that the process of our equation changes. We still are going to solve the equation how we normally would solve an equation. For example, number 1 actually is very similar to an equation like this. All right. In an equation like this, the first step I would do is I would subtract 4 from both sides. Same thing in number 1. I'm going to start off subtracting 4 from both sides, and I wind up with an 8x is equal to a p minus 4. And then in this equation here, I'd end up with an 8x is equal to a 10. And then the next step I would do is I would divide by 8 on both sides in this normal equation. And then I would have x is equal to, and I would actually simplify a 10/8 to get both are divisible by 2, so that would be a 5/4. So same type of thing in this equation, this literal equation. I'm going to divide by 8 on both sides. And now I'm going to simplify. I would have x is equal to a p divided by an 8, which is a 1/8 p, minus a 4 divided by an 8, which a 4 and an 8 are both divisible by 4, so I wind up with a 1/2. And this is my answer. I just leave it like that with the variable in there. You can see that the process that I went through in number 1 is very similar to the process that I would go to in a normal equation. I'm going to erase my normal equation work, but that was just an example to show you that I'm going to solve exactly the same way that I would solve a normal equation. Number 2 is very similar to the equation 7x minus, let's just do 7x minus 4 is equal to 14. So these two equations are similar. In the red equation, what I would do is I would add 4 to both sides, and I'd be left with a 7x is equal to a 14 plus a 4, which is an 18. Same on my number 2. On number 2, I'm going to just add y to both sides instead. And I would wind up with a 7x is equal to a 14 plus y. Then to finish off the blue equation, what I would do is I would divide by 7 and then simplify the 18 over 7 to get my answer. Same thing in my green equation. I'm going to divide by 7 on both sides, the same process. And so I wind up with x is equal to, and now I'm going to simplify. A 14 divided by a 7 is a 2, plus a y over 7 is the same thing as a 1/7 y. If you wrote it as a y over a 7, that's completely okay. But again, notice the process that I did in number 2 is exactly the same as the process that I would do in a normal equation. So that normal equation was just an example to help walk you through number 2. All right, number 3. Number 3 is a similar equation to, let's say, x plus 4 over 3 is equal to 5. In this equation, what I would do is I would first multiply by 3 on both sides. So I'm going to do the same thing, and I'd be left with an x plus a 4 is equal to a 15. I'm going to do the same thing in number 3. I'm going to start off by multiplying by 3 on both sides, and I would wind up with an x plus a y is equal to a 15. Now in my red equation, what I would do next is I would subtract 4 from both sides, and I'd be left with x is equal to 11. In my blue equation, I'm going to do the same exact thing, but instead of subtracting 4, I'm going to subtract y from both sides, and I have x is equal to a 15 minus a y. And that's it. I solved for x. I isolated x, so I'm done. Again, this stuff on the right side was just an example to show you the process that we would do for number 3. It's the same exact process as solving just a normal equation. All right, So now I'm not going to do the normal equations side by side. If you want to keep doing that, that's fine. But number 4, I'm just going to jump straight into my literal equation. I'm trying to solve for x. So since I'm trying to solve for x, and x is in the numerator, and there's technically imaginary parentheses around this numerator, and when we solve equation, we deal with parentheses last. So what I'm going to first do is I'm going to multiply by a y minus 1 on both sides. But since I'm multiplying by 2 terms, I need to put those 2 terms in parentheses because a y minus 1 divided by a y minus 1 cancels out and I'm left with the x plus 2. But what happens on the right side is this 2 needs to be multiplied by the whole y minus 1. So I do need to distribute that 2 into parentheses, so I have a 2y minus a 2. And then now, to get x by itself, I have a plus 2 attached to that x, so I'm going to subtract 2 from both sides, and I wind up with x is equal to a 2y, and then a negative 2 minus a 2 is a minus 4. X is solved for. That's my answer. Now, number 5 is a little bit tricky, and I'm just going to give you a tip here. If the variable that you're trying to solve for, which we are, is in the denominator, which it is, we need to get it out of the denominator of our fraction. So it might be very helpful for you to get rid of the fraction in general by multiplying both sides by x. That's exactly what we're going to want to do. So when I multiply both sides by x, I'm left with an x times a y is equal to, and an x divided by an x cancels out, and I'm just left with a y on the right side. Now, this is nice because now I don't have to work with fractions. I'm not working with those fractions. And so now I can just solve for x. I have an x times a y, so I'm going to divide by y on both sides. This y divided by y cancels, and I'm left with an x is equal to, and a y divided by a y is a 1. So x equals 1. We actually came out with a number answer for this one. All right, I'm going to show you 2 different ways to do number 6. The first way, you could get rid of fractions by multiplying the whole entire problem by 3, if you wish. So a 3 times a u is a 3u. And that will equal a 3 times a negative 4/3 x. The 3's cancel out, and I'm left with just a negative 4x. And so now I don't have any fractions to deal with. My goal was to eliminate the fractions, which I did by multiplying the entire equation by my denominator of the fraction that I had here. Now I'm solving for x, so I'm going to divide by negative 4 on both sides. So I wind up with a negative 3/4 u is equal to an x. If you want to leave it as a 3u over a negative 4, that's okay. That's the same thing. That's one way to do it. I'm going to show you another way to do it right on the side of this. So I'm going to separate the 2 sides. And again, we're going to have the same original equation because I'm showing you a different way to do this problem. All right, well, some of you guys might have thought, well, this negative 4/3 is being multiplied by x, so to undo multiplication, we're going to divide by negative 4/3. That is not okay because we should never, ever divide by a fraction. All right. Instead, you guys might have learned something called the reciprocal. In fact, actually, I know that we learned it this year. The reciprocal of a fraction is the fraction flipped around. And instead of dividing by a fraction, what we can do is we can multiply by the reciprocal. And that's technically the same thing as dividing by our fraction. So then I have a negative 3/4 u is equal to, and a negative 4/3 times a negative 3/4 cancels out, and I'm left with x, which is exactly what I wanted to solve for. Notice I get the same answer regardless of the way that I do number 6. All right, and now we're going to move on to number 7. So right now I have y is equal to a 4 times an x squared. Order of operations backwards, we deal with the exponent after we deal with that multiplication. So we're first going to deal with the multiplication. 4 times an x squared, to get rid of the 4, I'm going to divide both sides by 4. So I really have, you could leave it as a y over 4, or I'm okay with you writing it as a 1/4, a 1/4 y. Either way, it's up to you. And we're left with an x squared. All right, I'll show you both of these ways. Whether you wrote it as a y over 4 or a 1/4 y, I'm going to show you both ways. Now we're going to deal with that exponent, and this is something we haven't really done before, but to get rid of an exponent, we're going to take the square root of both sides. And I'll show you this way as well. When you take the square root of both sides, the square root of an x squared is just an x. So now we solved for x. The square root of y is just the square root of y. But the square root of 4, you guys should know that. The square root of 4 is a 2. So I have the square root of y over 2 as my answer. Or if I was doing it the other way, the square root of x squared is an x, so I still wind up with x here. The square root of 1/4, the square root of 1 is a 1. The square root of 4 is a 2. And then the square root of y is just the square root of 4. So these two are exactly the same thing. A 1/2 times the square root of y is the same thing as the square root of y over 2. And I don't care which way you write it. But that brings us to the end of this lesson.